Hello everybody and welcome back. We're on question number 18 from our 2018 grade 7 Gauss math contest. Okay, so hopefully you've taken a look at this question. I'm going to take my first gander at it right now. We'll see what we can do. So question 18, there are several groups of 6 integers whose product is 1. Okay, so immediately that catches my attention. Integers whose product is 1? If I take, regular old integers like 2 and 3 or negative 2 times, 5 or something like that, we get numbers that are very, very big in terms of their absolute value. They're very far away from the number 0 and also the number 1, actually. But product being equal to 1, well, 1 doesn't really have many factorizations. You can do 1 times 1, or you can do minus 1 times minus 1, but that's the only way to break it down into integers. Okay? You can do 2 times a half and things like that, but a half isn't an integer, so that doesn't count. Alright, so integers whose product is 1, immediately I'm starting to think a bunch of 1s and minus 1s. So which of the following cannot be a sum of such a group of 6 integers? So we've got minus 6, minus 2, 0, 2, 6. Okay. So with a question like this, having already decided that, okay, these integers sort of have to be 1s or minus 1s, given the multiple choice nature of the contest, I think it's probably easiest just to go sort of from left to right and say, can I think of a way to multiply 6 integers together, have it equal 1, and have their sum be minus 6? And we can play around with it. But, of course, there's only so many possibilities we can have. If we think of these numbers, 1 is equal to something, times something, times something, times something. There's only so many ways to fill minus 1s or plus 1s in here. And so if we're trying to equal minus 6, well, if I have 6 of them, any 1s and minus 1s are going to cancel each other out when we add them together. If I want minus 6, I'm really going to have to be looking at all minus 1s. But 6 minus 1s add up to minus 6. So that works out. And as we do this, we can also start to realize a few other things. There's going to have to be an even number of negative 1s. Okay? What was the next one? I think minus 2. It's going to have to be an even number of negative 1s. Otherwise, you'll have too many minus signs. And if I get rid of even just one of these minus signs, I've got 5 negative 1s. That all multiplies to negative 1. Multiply it by this 1 here, and we'd get negative 1, not the one that we want. Okay. So we need an even number of minus 1s. That also narrows things down tremendously for us. So, okay, I want minus 2. Clearly 6 negative 1s isn't going to help, but maybe we could try 4 negative 1s. And I guess the other 2 would have to be 1s. And when we do that, we realize, well, this negative 1 and this 1 and this negative 1 and this 1 could cancel out, and then, yeah, we do get negative 2. So that works out. We could try 0 next. So 0, remember, each negative 1 and 1 cancel out, so I need the same number of 1s as I have negative 1s. But then I break my rule that says I need an even number of negative 1s. So I'm beginning to suspect this won't work. And if you're confident at that point, you say, all right, C, 0, that's the answer. Okay, we've got pretty good evidence. The only way to make 0 would be to have an equal number of 1s and minus 1s. But that means 3 minus 1s, and that would mean a product of negative 1s. So, But if you want to make doubly sure, and if you've got the time, you can check the other 2 pretty quickly. Okay, so the answer is C, by the way. But we can do the others, 2 and 6. You get 6 by doing 6 1s, just like we had 6 negative 1s before. And 2, you do 4 1s and 2 negative 1s, the only other possibility. Okay? And there we go. And these 4 are the only ways to make a product of 1 using 6 positive integers. Okay? 0 really is the odd one out here, and so C is going to be our answer. We bubble it in. We get ready to move along to the next question. I'll see you next time.